Ladies and gentlemen, hello to everyone. I'm glad to be here with you today, even distantly, to represent my work paper entitled A Secure Network Coding-Based Approach for a Confidential Multi-Hop Routing in Wireless Sensor Networks, SNCR. I hope you are doing well. Let's start. I am Hana Rahim, a PhD student from Higher School of Communication of Tunis, and this work is under the supervision of my thesis director, Professor Siham Kamara, and supervisor, Madame Rima Abbasi from SIGAPP, as well as Professor Damien Sobran and Mr. Karim Tamim from University of Limoges. I'm going to start this presentation by giving a brief introduction and context of the work. Next, giving the problematic and objectives of the paper. Following up with describing the proposed solution, then giving a brief discussion of this solution, and last but not least, presenting conclusion and perspective work. So, what is wireless sensor network? It's actually a set of distributed autonomous sensor nodes which are deployed in different environments in order to sense data collected and transmitted to the base station. Its application, the earliest one was military field for surveillance and control. Later, wireless sensor networks are used for several applications. These pictures show some of them, like fire detection in forests, agriculture, body sensor network, and several medical applications. And wireless sensor network can be even integrated in several smart systems like smart city. So, let's quickly introduce the main technique used in our paper, the network coding. Unlike the store and forward communication pattern in networks where nodes simply store received packets and relay it without any alteration, in the network coding enabled communication pattern, the relay nodes recode the received packets using an encoding vector and combined generated packets before sending them. Network coding was originally proposed for increasing the throughput performance. The existing problematic and objective of our work. With networks designed to be deployed in large scale for many wireless sensor network applications, with a dynamic topology and very dense network, these latter suffers from energy limitation to run their services. A sensor node of a very small size and small storage capacity, as well as low calculation power, affects network services, disturb its connectivity and load balancing, as well as it can make even distant nodes die quickly. So, the main first problem with this technology is energy resources fast draining. Moreover, majority of wireless sensor network applications require at least some level of security. In order to achieve the needed level, secure and robust routing is necessary. However, most routing protocols for wireless sensor network were not designed with security requirement in mind. It's to mention that security is energy expensive when applied to wireless sensor network. The problem is how to create a compromise between efficiency and security. This work creates a trade-off between security and energy. It actually proposed a network coding scheme that ensures security aspect, mainly data confidentiality against the eavesdropping attack. Moreover, it increases the gain in energy consumption using an optimized version of a network coding technique which preserve more energy compared to traditional network coding scheme. Let's move on now to the proposed solution. It's to mention first that the algorithm is developed with a hierarchical clustered network, the same topology used in our previous work on efficient routing for wireless sensor network. As a result, more energy preservation and load balancing will be ensured. Our proposition, called SNCR, is built upon three phases. SNCR, secure coding based approach routing or routing protocol. Okay. So it's built upon three phases. 1. An encoding process within member nodes. 2. A second encoding process within cluster head nodes. 3. A decoding process within the base station. Each sensor node is preloaded with a unique matrix ME shared with the base station. ME is a matrix of a large size and contains randomly chosen coefficients. The attacker can be divided into two types. First one is an internal node, which write-ups on data, mainly a CH or aggregate node. A second type is an external node, which listens to data flow, an eavesdropper. Let's start now explaining the three main phases responsible for data confidentiality against the eavesdropping. The first encoding process starts with coefficients choice. More specifically, each member node NE chooses randomly a member PE within the range of the maximum matrix size. Then it pinpoints the matrix coefficient having that position and extracts a list of size square T values starting from the previous pinpointed one. As a result, the coding vector for NE required for data coding is built. To collect T data samples, we assume here that each sensor node transfers data after T periods of sensing. So here, the sensor node derives the T-coded samples using the following system of equations. Then it sends these letters along with PE value to cluster head. The second encoding process starts with data concatenation. In fact, each aggregate node AGE concatenates the received data samples from all its cluster members by assembling those having the same position E, generating the following ones. As a result, the number of packets resulted is reduced from S multiple T to T. Then the aggregate node AGE calculates its own value PG from the ones received from its cluster members and do the matrix coefficients extraction using this mentioned formula PG. Next, AGE generates a second level coded samples using the system of equation S2 and send the following packet containing IDs and PE values of member nodes along with coded data to the BS, of course. As we have mentioned, the BS receives the following packet from each cluster head or aggregate node S here being the size of the cluster. Next, the coding process within the base station is proceeded as follows. For each received packet, it calculates the sender value PG and extracts the sender used coefficients to code. Then, the base station calculates the created packets within the aggregate node via the system S2. Following that, since the BS is aware of the size of each cluster, it divides each concatenated packet into S equal partitions to bring out first level coded samples. After that, it extracts coding coefficients used by member nodes from their matrices, exploiting the received values of IDs and PEs. So, finally, the EBS calculates the original data via the system S1. So now we move to discussion and validation of the proposed solution. Discussion part. As we have mentioned before, the adversary can be an external node to the network or an internal one to the network. In the first case, listener 1 intercepts the following packet but can reveal nothing about original data because the matrix M is being hidden with the node. Same thing with listener 2. When receiving the following data, he can reveal nothing since values are random and not related, as well as matrices are hidden. In the second case, the adversary is an aggregate node in the cluster. Receiving these following packets, he cannot reveal data because the nodes are not related, and similarly the value PE are random. A main contribution in our work is that SNCR technique minimizes the overhead compared to conventional network coding system. In fact, a node NE or IGE joins only a single value PE to the coding vector to be sent and not all square T coding coefficients. As a result, SNCR increases the gain in energy consumption. Moving now to the conclusion and perspective part. In this paper, we have proposed a secure confidential routing protocol called SNCR, Secure Network Coding Based Routing Protocol, using an enhanced version of network coding. SNCR can be integrated into an energy-efficient multi-hop communication pattern within a hierarchical network in order to maintain a load-balanced network. In fact, this is what we have proposed. This secure protocol is integrated with a previous work of a routing protocol that focuses on energy. So the output of this work is to create this trade-off between energy and security. So now, talking about perspective and future work, we aim to consider the denial of service attack where relay nodes refuse to forward the encoded packets the way to the BS, the base station, affecting though the data availability. These particular relay nodes are called selfish nodes. That's it. Thank you for your attention. For any question.